Episode 2 of Tech Train Solutions. Welcome back to Tech Train Solutions. In today's episode, we're diving into how motors are controlled in industrial settings using PLC programmable logical controllers and motor controllers, whether you're new to automation or brushing up your skills. I am here to help you out, to help you build a solid foundation in the electrical world. Here is an example of a motor controller. What is a motor controller? A motor controller is any device that governs the performance of an electrical motor. It can start, stop, reverse, and regulate speed or torque. Common types are contactors. This pulls in and runs a motor, forward and reverse right here. That is used for starting the motor at full speed. There's no variable. Variable speed drives, VFDs. That is used to vary the speed of the motor, forward, reverse. Depends on what you use. This uses analog to help control speed. MCC controls center that has either or. This one right here either has a contactor or a VFD in these what we call buckets. They are the different types. So how does a PLC interface with a motor control? PLCs are programmable logic controllers. Think of it as the brain of the system. They send control signals to the motor controllers based on the input conditions. For example, think about this. A PLC might receive this signal from a center of a product, like, for example, a beer can or a bottle coming across, and its only mission is to stop at a filling point. So they'll probably use a photo wire sensor that will go to that point, and the sensor will see it, stop it, and what it does, it blocks the beam of light, closes the switch in that photo eye, sends it to the PLC. PLC recognizes it through the programming which you did and sends an output to tell the motor to stop. Okay? That's basically it. Just like a light switch. You turn on a light switch, it sends power to a light, giving you light. So you are the PLC turning on the switch and turning on the output. You're the input, turning on the output. PLC is doing the same thing, except for a little bit more programming. You have put your start and stop circuits in the programming for that purpose. Let's show you an example of PLC programming and inputs and outputs and contactors. Let me show you all different types. This is from the MCC I was talking about. The MCC is showing power coming in. That circuit breaker fuse disconnect. It's going across to the motor. See it right there? Now, this right here is a transformer. Transformer is for a purpose. Transformer is meant to lower this voltage to a lower manageable voltage for start and stopping the motor. So you have power going across. This is the motor M. Crossed off, lighting this light saying I'm running. I'm off. Here's the start and stop. This point here is called normally closed, stop button. Going over to a start button, normally open. When I push the start, closes this, activates the M for motor, this right here. The motor's running. When it's running, it opens this saying, hey, I'm no longer off. And because it's running, I turn the light on saying I'm running. This is what you call a 3-wire start and stop circuit. This is contactors right here. Pretty simple. Simple, easy. This right here is the PLC portion of it. The PLC portion. You have, right here, it's hard to see, but I have start buttons. These are push buttons here, right? This is just a trainer. That's why it says PBL, but usually you can use these as push buttons. Inputs in the field going to a PLC. So when I push down on this, that 3 and 4, it closes the circuit, and through some kind of programming, either runs the motor or puts it in ready state, and then you hit another button to start it. And underneath here, you see something called photo eyes. Again, a sensor sending out a beam of light. 24 volts in, DC in, and when I close my 24 volts, it sends an output out of the sensor to the input of the photo of the PLC card, saying, "Hey, I'm blocked." This is a simple way that PLCs activate and run. Here's an example of a PLC card with the lights active. As you see here, it says PE99, 100, 101, and so on. The red light means I'm blocked. Clear, black could mean off. But again, photo eyes have two different states. They have something called normally open, normally closed too, so it depends on that photo eye setup. Here's another example of input. This is a different older system called Modicon. What you have is outputs this time. This output's turning these lights on, saying I'm running. Bang, light. Right, that's from an output card. Here's one with inputs, older card. Inputs are telling me that, hey, the disconnect is open or closed. This one's saying I have I have power available, and this one says 1100. This is for a photo eye. Photo eye, right? Photo eye is blocked or not blocked. These are many different ways in which we control motor controllers out in the field in different industries. Lately, they're going more with AI, more smarter ways of doing it, but you still need some kind of controller turning on and off. So even if they use AI, you'll still need a PLC there turning on and off the programming, the outputs and inputs. I'm going to give you an example of a PowerFlex, a drive. This is a drive print. I know it's kind of messy. This is me from work when I left. But this is showing different points of a drive. I have my power in, L1, 2, L3, T1, T2, T3 is my power out to the motor, with my many different inputs and outputs, making this drive run for a reverse. This is an example of that. Now you have other different types of motors, drives. You have something called servos. This is a print of a servo. Servos are very detailed, very exact. They have something called encoders. Encoders have probably like 30,000, maybe more points of reference inside the circle if going around and around. It's very detailed. It stops on a dime. It's very accurate. It's used for motion when you're building something, making something. This is used, called the servo system, servo drive system. That is very smart. Now let's look at real world application. Look at this. Real world. This is a baggage claim that probably has either a start and stop physical push button, or it has a VFD controlling this. Another real life is when you get your package from Amazon. Look, conveyor systems. I used to work on conveyor systems my last job. You have conveyors feeding something. This one is like a sorter, so this is probably going this way, and it's going to be diverting into this point. All right, it uses a photo eye and timing. This is probably timing here, but these right here are little photo eyes. All right. Photo eye blocked, it probably runs this motor. Photo eye blocked, runs this motor. Blocked, photo eye runs. And then the robots also probably have sensors in them. All being programmed by a person like you. Medical processing. There's another real-world application of motors being used. This is different, though. So what's going to happen here, different than the other one, is probably a clear bottle will go to this photo eye. Oh, I got a clear bottle in front of the photo eye. Let me get ready to fill it. All right, so now it's going to wait to be open, move it, bottle to a filling station. The filling station probably have a sensor too, say, hey, there's a bottle there, let me fill up. Then it probably moves to another location, says the sensor probably looked to make sure all the pills are there. All right, that's what this does. The sensors work in conjunction with each other in the motor. Filling can station. Now, all this is done through a PLC, but also through a certain control. It can't just go fast or slow. It's got to vary. One way it varies is something called analog output. Analog or input, either one. Analog means variable. Input and output is on or off. Analog output or input is it's variable. So I'll give you an example of the different types of variables. So for those who don't know electrical, just bear with me. You have something called 0 to 10 volts. Between that is 9 volts. So at 0 volts, that means I'm stopped, nothing's running. But when I send 5 volts to my drive should run half speed. So I've got 60 hertz is my full speed. 30 hertz is going to be half speed. I have another one called 0 to 5 volts. Difference with that, usually 0 to 5 volts is usually used with weight. I don't see it too much with motion. The last one, it's an older system, but it's still used, is 4 to 20 milliamps. They're all used. But 4 to 20 milliamps, 4 milliamps, not running. 20 milliamps, full speed. That's the different type of analog signals you have there. It depends on how you have it set up. You can have low numbers be full speed or high numbers be full speed. It depends on how you have it set up. That's what I'm showing you. So that's one way. So example, let's say you go to your HMI station, all right? You hit the start button. Start button's hit. Activates a VFD. VFD now lets the motor run. Product's going to run to the sensor here and stop and then be picked up. That is an example of automatic system, a PLC controlling this system. That is an example of it. A manual system, let's look at this. This is a manual system. This is usually what's been out there, still out there. People don't want to pay the money. You're start and stop basic systems. You hit the start button. The 2 circles underneath means it's normally open because it's not touching. The stop button, 2 circles underneath being connected means it's normally closed. C for contactor. This contactor is going to hold itself in. I hit start. Power will be pushed through, pulling this contactor in. This right here will hold it and keep it holding it until you hit that stop button. This is your basic 3-wire start and stop system. That is another manual way of being done. It is easy to use. This is so quick to be put together of how to do different systems. Now, let's go back into the PLC world. Sometimes you will have to program that. So it's not that hard. You just need to take your time with it. But it still takes physical wiring to do the whole process. The wires we run to the PLC, to your sensors, to your start and stop systems, your push buttons. That is what it's being used for. So let me show you an example. This is something called a ladder diagram. Same concept as you saw before, but the ladder diagram. If you look to the left and look to the right, a little different, but still, same concept. Ladder diagram is a PLC rung. You have something that says on, so when this closes, this becomes active to a photo eye. When this turns on, it closes, activating this coil, which is the same concept. This is like a holding contact. See right here, PS1, PS1, they're the same. So this acts like a holding contact until one of these opens up. Same, start and stop, logic, it's not that difficult versus hardwire. Motor will only detect once you get this closed. I gave you other examples of controls with the Amazon packaging, FedEx, UPS. This is everywhere, and you need to get yourself into this world. I just talked about servo systems. Servos are very exact. They literally move where they're told without much variation. Just think of your favorite soda, favorite beer, your product, toilet paper. All this is made through motor control systems. It is everywhere. So enjoy this video. Please comment and tell me what you like, and I will make more videos in the future. Thank you, and have a good day.